We're going to continue to discuss ionic compounds and ionic formulas here in this next section, beginning with a discussion of formula units. So, a chemical formula shows the kinds of atoms and the number of atoms in the smallest representative unit of a substance. For an ionic compound, that lowest whole number ratio of ions is called a formula unit. Every ionic compound has a 3D array of positive and negative ions that shows how they are arranged. So for sodium and chloride ions, so sodium chloride, table salt, we see the sodium ion surrounded by these green chloride ions in this cube lattice shape. So the question becomes, how do we get from this arrangement to the written formula that we see for sodium chloride or any other ionic compounds? So here's how we write an ionic formula. They don't always combine in a 1-to-1 ratio because remember that the overall ionic compound has to be electrically neutral. So we don't see a 1-to-1 ratio because all of the positive ions have to be balanced by all of the negative ions. So here's how you can determine the formula for an ionic compound using magnesium and nitrogen as an example. First, write down the common ion that's formed by each atom, including the charge, and always write the metal or the cation first. So cation always comes first. So here we have magnesium, which commonly forms a 2+ cation, and nitrogen, which commonly forms a 3- anion. Then we just do this quick and dirty method called crisscrossing. So we crisscross the numerical values of the charges, writing them as subscripts. So we bring the 2 down here. You can see the 2 in blue. And the 3 down here, you can see the 3 in red. And we drop the signs. Remember, there's no overall positive or negative. So we just drop it. And then reduce the subscripts to the lowest ratio if necessary. So this is the lowest ratio here, 3 magnesium ions for every 2 nitrogen ions. And we have an overall formula, Mg3N2. Let's show another example here to write the formula for the compound formed between calcium and sulfur. So we have calcium, which forms a 2+ ion, sulfur, which forms a 2- anion. If I crisscross and write those charges as subscripts, I get Ca2S2. But I can reduce this because what this says is 2 calcium 2+ ions and 2 sulfur 2- ions. I don't need to say that I have 2 of them. I just need to show the lowest ratio of cation to anion. So I can reduce this and just write for every 1 calcium 2+ ion, I have 1 sulfur 2- anion, or I have an overall compound of CaS.